Yeah, screen is visible to all.
Yes, sir.
Yeah, we'll see network equilibrium equations. Okay, today we'll see about some network equilibrium equations. Okay, network equilibrium equations. For that, first you guys can stop me at any time. If any doubt arises in the sense, you can stop me. I will explain that. We need to know about KVL law, Kirchhoff's voltage law, and Kirchhoff's current law. Okay, KVL, KCL. Already we know how to draw this one for linear networks, right? Took only for graph, matrix format and all. We are going to see today in the network equilibrium equations. Okay, first KVL. Here Kirchhoff's voltage law. First one. Okay, now what KVL states that summation of voltage drop across a path or in a closed loop equals to 0, right? Here KVL states that, I can say KVL states that if Vk is the voltage drop across the kth branch.
Sir, the video is lost.
Here K is a branch, Vk. Here what's it saying? KVL states that if now it's visible, right? No?
Yes, sir. Yes, sir.
Yes, sir. Yes.
Vk
Now visible.
is the voltage drop across the kth branch. Then we are going to write summation of equals to 0. Okay. Of Vk equals to 0. Where this summation, the sum of the voltages over all the branches. Okay. Here if L is the number of loops, or we can say loop circuit, that is, or F circuits. L is the number of loops or F circuits, then there will be a L number of KVL equations. Means how many loops are there, that many KVL equations. For example, if I am having 3 loops, see here, if I am having loop 1, loop 2, loop 3, then I am going to get 3 KVL equations. Okay, one for each loop. Then the KVL equation for F circuits or KVL equation for loop L can be written as summation of K equals to 1, B is the branch here, BIK Vk equals to 0, where BIK is elements of die-set matrix, elements of tie-set matrix. We are going to denote the tie-set matrix as, we already know, we are going to denote this tie-set matrix as capital B. Capital B. Yes, Bik is the elements of tie-set matrix B. Okay. Now here B is the number of branches. Number of branches. Okay. Here K is the kth branch. B is the number of branch. K is the kth branch. If you want to say V some P or VP, pth branch, like that. Okay. Now here B is the branch. Tie-set we are going to denote as a B. B is the number of branches. Okay. Then the set of L, that is nothing but set of loop equations F cuts F circuit KVL equations can be written as, okay, for set of L loop equations, L KVL equations can be written in matrix form as capital B tie-set matrix, then VB, that is branch voltage VB equals to 0, where I can say VB is a column matrix, that is V1 V2 up to VB, up to branch B. These are nothing but V1 V2, so B are the branch voltages. Okay, B is the tie-set, you can call it as a fundamental circuit matrix. This is the basic of Kirchhoff's voltage law. Next is a, see, any doubt in that graphs? Right?
Sir,
That is the basic
can you
of KVL. Yeah.
sir open that screen, sir, once?
Column matrix. Where? This one, right? V1, V2 up to VB, up to branch B. These are nothing but V1, V2, so on up to VB are branch voltages. Okay, B is the tie-set matrix, or we can call it as a fundamental circuit matrix. Yes. Any doubts in this?
No, sir.
Yes. Now we will see the KCL. Kirchhoff's, it means how many loops are there, that many equations. And the total summation, as we can say, voltage drop across a path is equal to 0. Means summation of all the drops as well as the voltage source is equal to 0. That is summation of Vk equals to 0 here. Voltage law. Next is a Kirchhoff's current law. Kirchhoff's current law. There is KCL. Here same. The KCL states that if IK is the current in the kth branch, if IK is the current in kth branch, then at a given node, there at a given branch, okay, kth branch, then at a given node, in KVL at a given branch, here in KCL at a given node, I can say summation of IK equals to 0. Okay, now the sum being taken over all the branches incident at a given node. there are n nodes, there will be a equations. If, for example, okay, this is my graph. Okay, how many nodes are there? 1 2 3 4. This is base node. Okay, leave this. 3 equations we are going to get for each node. 1 2 3. Okay, now the sum being taken over all the branches incident at a given node. It means simple, I can say in this node there are 3 incident branches are there. So whatever the current is flowing here, we are going to take that sum. Here I1, I2, I3 I can assume, then I1 plus I2 minus I2 minus I3 to 0. This is summation of I equal to 0. This is some example for this. Now the sum B is taken over all the branches incident at a given node. Okay, now as like I'm going to say summation k equals to 1 to B aik, there bik, aik, ik equals to 0. Okay, so that set of n equations can be written in the matrix form as a b aa ib equals to 0. We know that a is a complete incident matrix. Okay, where ib can be written as I1 I2 up to branch B. Okay, where I1 I2 IB are the branch currents. I1 I2 IB are the branch currents. It's a column matrix IB. Okay, A is the complete incidence matrix. Fine. AIK is the branch elements. Now if one node is taken as a reference, this is a complete incident matrix. Okay, for incident matrix what we are going to do, we are going to eliminate one row for writing from AA. If we are going to eliminate any one of the row, then we are going to get capital A, that is incident. Fine. Now if one node is taken as a reference, or I can call it as a base node or datum node, you can write the equations as for this A. This will be, if one node taken as a reference, this equation become as AA become as A, then IB equals to 0, where A is the incident matrix. A is a complete incident matrix. This of the order n minus 1, number of node minus 1 into number of branches. Okay, now we know that incident matrix is equals to, we know the relation that incident matrix equals to twig of that incident matrix into Q. Q is cut set, my F cut set matrix, fundamental cut set matrix, capital Q. Correct? Okay, we know that there is a relation between incident matrix and the fundamental cut set matrix. Then my equation AIB equals to 0 will become AT Q IB equals to 0. I am replacing A with ATQ, this one. Then my equation become ET capital Q into IB equals to 0. Correct?
Where ET is nothing but the
just replacing
incident matrix.
this A with this. Okay, then pre-multiplying A transpose AT transform to the both sides. If I am going to multiply A transpose on both side A transpose this one ATQ IB equals to A transpose is 0. Okay, now it will become as I Q IB identity matrix. One matrix transpose into that matrix itself will become as an identity matrix I Q IB equals to 0. So I can write Q IB equals to 0. Okay, where Q is the cut set matrix. This is the basic idea behind KCL for.
See guys, where in a KVL we are going to use die-set matrix B VB equals to 0. Okay, here in KCL capital A IB equals to 0 or Q into IB equals to 0. Fine.
KCL for network equilibrium equations. Okay, now we'll see. We know how KVL and KCL are written for the network. Okay, now network equilibrium equations. First, in this we are going to see KVL equation. Okay, first we are going to consider on a circuit. Okay, simple circuit, that is one impedance is in series with the voltage source. Okay, this is a reference Vk. Current I is, this is a kth branch. In kth branch current Ik is flowing. The kth branch impedance will be Zk. Then voltage source of that k branch is Vsk. Okay, plus minus. Fine. Now here on voltage source is there in a branch k. Fine. Now we can write Vk equals to Zk Ik.
See, I am just applying my KVL for this circuit. Okay, Vk Zk Ik
minus Vsk. Don't confuse with this. Here first, see here, if I am going to take this path, okay, what I am going to write, plus minus here, plus Vk, see here, plus Vk, then
minus Zk Ik
minus Zk Ik minus to plus Vsk equals 0 for this path, plus Vk minus Zk Ik plus Vsk equals 0. If I am going to take Vk this one that side, then Zk Ik minus Vsk. This is only I have written directly here. Vk equals to minus Zk Ik minus Vsk. Okay, K is the branch, so I can write K equal to 1 to up to B branches. Fine. Now where this is the equation for this kth branch. How I am going to write this one in a matrix form? in matrix form I can write this one as VB equals to branch voltage VB equals to ZB branch impedance, IB branch currents minus of Vs, that source of that branch. Okay, here 1 minute. Okay, now Vb equals to ZB IB minus Vs. Fine. Where Vb is the branch voltage, ZB is the branch impedance matrix, IB is the column matrix, or I can say column vector. Vs is the column vector of the source voltages. Hence KVL equations can be written as, you already know.
Tell me how we are going to write the KVL equation. That simple one, first basic we see in KVL, right? Now tell me the formula for that. Dissect matrix into, yeah, anyone? Yes.
BVB is equal to 0.
Dissect matrix into VB equal to 0. BVB
Sir, audio is off.
audio. Now
No, sir.
it's not coming.
No, sir.
No, sir.
No, sir.
Wait.
B into ZBIB minus Vs.
Now it's
equals
coming,
to
right?
0.
Yes, sir.
Okay. With this, BZB into IB, then B into Vs minus B Vs. If I see B Vs equal to 0, B ZB IB equals to B Vs. Okay, where B is the cut set matrix, correct? Sorry, tie set matrix. Then also we know, also IB is equals to B transpose IL. This one we need to remember. See here, IB is equals to B transpose IL. IL is the that loop current, F circuit currents. Okay, B T is tie set matrix. Okay, IB is the branch currents, that is a vector, column vector. Okay, now if I include this one in this equation, B equals to ZB, then B transverse IL equal to B into Vs. Fine. Now I can say I'm going to take E equals to BVS. Okay, then Z equals to B ZB B transpose. Then I can write ZIL equals to E. Okay, now Z is called, this Z is called a loop impedance matrix. I can write BZB B transpose IL equals to B into Vs, that is ZIL equals to E. Okay, this is my network equilibrium equation for this circuit. Okay, now I'm going to take another circuit where current source will be in parallel with this circuit. Okay, we'll see that one. Here circuit, impedance, voltage source, then one parallel current source. Okay, here Vk, Ik plus minus Vsk, Isk. For this circuit we have to write a network equilibrium equation where the current source is in parallel with the voltage source which is in series with Zk. Okay, now first of all what I have to write for KVL? First we need to find out this Ik, where Ik, see here, where is that? Vk plus Vsk, Vk plus Vsk divided by Zk, Vk plus Vsk divided by Zk, then minus Isk. Means at this point I am finding out this Ik. I can write there Vk for KVL, Vk equals to,
say I just applied KCL at this node where Ik is equals to Vk plus Vk plus Vsk divided by Zk. This is nothing but the current in this branch. Okay, then the minus of source current Isk.
Zk Ik plus Zk Isk minus Vsk. In matrix form, Zb plus Z minus V. This Vsk is Vs in matrix form. Okay, now we know KVL equations can be written as B into V, Vb equals to 0. Okay, I can write B into this Vb, B into ZbIb plus ZbIs minus Vs equals to 0. Fine. After simplifying, Ib equals to B transpose IL. Here also see Ib equal to B transpose IL. With this, if I simplify this equation, okay, I can get Z IL equal to BVS minus BZB IS. Okay, where Z will become as Z equals to B into ZB B transpose. This is a loop impedance matrix.
See, someone is making that sound. Please unmute, mute yourself.
For this also you can see B equal to Z equals to B into ZB BT. Here for this circuit only I'll get BZB B transpose IL minus BVS. Okay, whenever I'm going to connect on current source here, the equations become as B into ZBIB plus ZBIS. Yes, this is a new term minus Vs. Okay, same I'm going to get Z equal to B into ZB B transpose. This is a loop, like Z equal to loop impedance matrix. Okay, now KCL equations. Okay, now KCL. For this I am going to consider this circuit. For KVL, what I consider? The circuit or that impedance in series with voltage source. For KCL, the admittance in parallel with current source. ISK, this is YK, the total VK, IK plus minus. Okay, this is a circuit diagram. If the branch K, this is a branch K, contains an input current source ISK, this is an input current source ISK, and admittance YK, YK is the admittance, ISK is the input current source, then I can write IK equals to YK VK, then minus ISK. YK is nothing but 1 by ZK, correct? 1 by ZK. Okay,
I can write
I
1 by admittance is equals to, sorry, 1 by impedance equal to 1 by admittance. This one YK to 1 by ZK.
K equals to YK VK minus ISK. Here also up to B branches. This is the kth branch I am writing. In matrix form, how am I going to write? IB equals to YIB VB minus IS. Here YB is the branch admittance matrix. Okay, and VB is the branch voltages. IS is the source current matrix. Now I can write A into IB equals to, already we seen in the KCL equation that A IB equals to 0 for KCL. For KVL, B into VB equals to 0. For KCL, A into IB equals to 0. Okay, now I know IB, just I am going to insert here YB IB YB VB minus IS equals to 0. Then it's become as A YB VB equal to A IS. Then VB, I know VB equal to A transpose Vn, node voltages. Okay, this one we have to remember. There B transpose IL. Here VP equal to A transpose Vn. Okay, if I am going to insert this one there, A equal to YB A transpose Vn equals to A into IS. Okay, then Y into Vn equal to I. Correct? Where Y equals to A YB A transpose and I equals to A into IS. Where A is my incident matrix. A transpose is my transpose of that inheritance matrix. YB is my admittance matrix. Yes. Okay. Now, the matrix Y is called as admittance matrix. This is admittance matrix. Okay. Now, this KCL equation, where while deriving that KCL equation, we introduced cut set also, Q. Okay. Now we can write the KCL equation as, see here. Okay. Q equal to IB equal to 0. Okay, then Q equal to IB, we know VB IB YB VB minus VS equals to 0. Yes, then Q YB VB equal to Q IS. Then we know VB equal to Q transpose VT, twig matrix. VT is a twig matrix.
See here, I have written Q into YB VB minus VX equals to 0. That is VS or IS? Minus VS is correct, huh?
Yes, sir.
Yes, yes.
Okay, if I am going to simplify this one, VIB Q transpose VT equal to Q into IS. Okay, why VT equal to I? So I can write Y equals to Q YB Q transpose I equals to Q IS. There are two KCL equations we can get. Okay, where A is the incident, here Q is the cut set matrix, incident matrix and cut set matrix. Okay, QIS I equal for this matrix like this. Fine.
Okay. Yes. Up to that, today's class, everyone understood?